Good morning. This recording is for Algebra 1, Chapter 8, Lesson 2, Multiplying and Factoring. Multiplying and factoring are opposites of each other. You're going to be seeing a lot of distribution today, and the opposite of distributing, especially with monomials up to trinomials and probably past that, is just distributive property. The only thing is that factoring is the opposite of the distributive property, which means you should be able to go between them quite easily. And just remember that everything in math has opposites. All right, so multiplying a polynomial and a trinomial. It's just triple distributive property. I do recommend that you add the opposite wherever there is a subtraction sign to turn numbers after into negatives, and this will help keep your multiplication straight and will help you keep your numbers good. Sorry, I have something in my eye. All right, taken care of. All right, so here's an example. We have 4b times the quantity 5b squared plus b plus 6. So those are b's, and that last number is a 6. All right, so let's go ahead and distribute. 4b times 5b squared, 4b times b, and 4b times 6. So there you go. Now, since it's a whole bunch of multiplication, but in 3 spots, let's go ahead and move some things around so you can see what actually gets multiplied. We have 4 times 5 times b squared, 4 times b, and 4 times 6 times b. All right? And remember, you can't add things that have addition or subtraction separating them because they don't have the same term. We have too many b's in the first area. We have 3 b's in the first area, 2 b's in the middle area, and only 1 b at the end. So we can't add these, but we can simplify them a little bit more. So 4 times 5, and there's the little invisible 1 above that first b, which means we have 20b to the third. Then we have 4b to the second, because we have a little invisible 1 on top of those b's, and we have 4 times 6, which is 24b. So that's your final answer, guys. It's just a whole bunch of distributive property. There's nothing too fancy about this one, okay? So let's do another example problem. We have negative 7h plus 3h squared minus 8h minus 1. And again, I recommend going through and adding the opposite. So I'm going to end up with a positive negative 8 and a positive negative 1, all right? See, I did do it in a different color, but yeah. Okay, so negative 7h times 3h squared plus negative 7h times negative 8h plus negative 7h negative 7h times negative 1. So let's go ahead and simplify a little. That's going to give us negative 21h to the fourth. And just remember, we have that, there's a 1 there, so it's h to the first times h to the second, which means this actually should be h to the third, not to the fourth, Miss DH. Let's see here. This should be h to the third. There we go, catching my mistakes. Okay, so the next one should be negative 7 times negative 8 is positive 56. We have 2 h's, which means we have h to the second. And then we have a negative 7h times negative 1, which is a positive 7h. So there you go. All right, guys, let's move on to factoring. Factoring is the reverse of the multiplication process. Basically, we're saying we're undoing multiplication, but not the way the division works, because when we factor, we're actually pulling things out of multiple term situations. And remember, a term is either a number or letter or multiplication of number and letter that is either being added or subtracted to another term. Basically, anything separated by addition and subtraction is a term. So factoring is the reverse of the distributive property. All right? So if I can distribute it, I can factor it. All right? So basically, we're taking the answers from the last slide and we're going backwards. We're pulling stuff out, and we're trying to figure out what had been multiplied or what had been distributed to all of those terms originally. Okay? So, to factor out a monomial from a polynomial, find the common factor of its terms. So first we're going to write the prime factorization for each. Now, if you can't remember how to do that, do a prime factor tree, which I hope you all remember how to do. If you don't remember how to do it, I can go over it in class. but a prime factor tree, breaking everything down into its prime factors, things that aren't divisible by anything else other than 1. And then we're going to find the common factors for each, combine the common factors, and pull that out and leave what we can not factored out. All right, so if we have 5v to the 5th plus 10v to the 3rd, what are the prime factorizations for 5v to the 5th and 10v to the 3rd? Well, 5 times v times v times v times v, 5 v's. We also have 2 times 5, or 5 times 2 times v times v times v for 10v to the 3rd. Remember, your prime factorization when multiplied together should equal the original term. 5 times 5 v's is 5v to the 5th. 5 times 2 is 10 times 3 v's is 10v to the 3rd. Now, I'm going to circle everything that is in common between the two prime factorization sets. So we have a 5 in each, and we have 3 v's in each. So that is the common factors. So it's going to be 5 times v times v times v, which is 5v to the 3rd. All right, so that's what I'm pulling out. Each of these factors have 5v to the 3rd in them, which means if they have 5v to the 3rd in them, I can take that 5v to the 3rd out and just leave what I have left over. So I've got 5v to the 3rd. What was I not able to take out of 5v to the 5th? Well, that would have been 2 v's, so v to the 2nd. And I keep the operation. So you guys remember that there's a plus sign in here, even though I just covered it up with an orange mark. There we go. There was a plus sign, and that plus sign stays because I should be able to then distribute what I get from this problem to get the original problem I started with. So what was I unable to take out of 10v to the 3rd after I took out 5v to the 3rd? Well, the only thing that's left is a 2. So guess what? That 2 still has to stay. So again, remember guys, factoring is the opposite of the distributed property. So if I can't distribute my common factor and get what I started with right here, then I haven't done my factoring correctly. So let's go ahead and double check real quick. So if I have 5v to the 3rd times v to the 2nd, well, it's a total of 5v, so it should be 5v to the 5th plus 5v to the 3rd times 2v is 10v to the 3rd. So since I got the original problem back out, I know that this is in fact my answer right here. All right, there's a lot of lines going on there. All right, but just remember, if you can't distribute your answer after a factoring problem and get the thing you started with, you have not factored correctly. All right, so there's your guess. There's your check method. All right, next question. We have a trinomial. Remember, this is a binomial, because remember, bi means 2, tri means 3. So if it's got 2 terms, it's a binomial. If it has 3 terms, it's a trinomial. And obviously, if it has 4 terms, it's a quadrinomial. All right, so let's go ahead and factor out. Let's make a prime factorization list for 4b to the 3rd, 2b to the 2nd, and 6b. There we go. So again, 2 times 2 is 4, and then I have 3 b's. 2 times 2 b's is 2b to the 2nd, and 2 times 3 times b is 6b. All right, so let's circle everything we have in common in the three rows. We have 3 2's and we have 3 b's. That breaks down into b times 2, or 2b. So 2b is the common factor, and it's what I can pull out of all 3 of those terms. What's left over in the first term, though? If I pulled 2b out of 4b to the 3rd, I am left with 2b to the 2nd. Well, that's my first term in my answer. And then I'm going to subtract, because remember, that's a subtraction right there. And then what was I left over with in the second term? Well, if I pulled out 2b, what I'm left with is a b. And then I'm going to subtract again, because there's a subtraction right there. Since I pulled out 2b out of 6b, the only thing that's left over is a 3, which is my final answer. There you go. All right, I have one more example problem for you, and that's to not forget placeholders. When a common factor can pull out an entire term, you still need to say that that term was there. It's kind of like a ghost one. It's like, that term used to be there, but because it like left the mortal coil or whatever, we have to say that it's this placeholder. Maybe you can even call it its gravestone. I don't know. But when you're factoring and you're able to pull an entire term out because it is a common factor, you have to leave a place value there as 1. So let's go ahead and show you how this works. So we have 24m to the third minus 12m to the second minus 6m. So let's go ahead and make the common factors. Hold on a second. Sorry about that, Mr. Michaels, and then a whole bunch of people walked in. Shh. So again, don't forget your placeholders. That's the big message of right now. So let's go ahead and do some common factors. So 24 m to the third would be 2 times 2 times 2 times 3 m times m times m. 12m to the second would be 2 times 2 times 3 times m times m. And 6m would be 2 times 3 times m. Circle the common factors. We've got 2's and everything, 3's and everything, and an m and everything. So the common factor is 6m. So that's what I've pulled out right there, 6m. So what's left over in the first term? 2 times 2 times m, which is 4m to the second. What's left over in the middle term? Well, that would be a 2m. So 2m. And again, I'm using the subtraction from there, guys, to keep it. You have to keep that sign. If they were plus, they were plus. If they're subtraction, then you've got to keep the subtraction. Now, as you can see, for the third term, 6m, there's nothing left. We pulled everything out using the common factor. So we still have to say that that third term exists. And so to say that third term exists, we're going to say that it is a 1. Okay? Because there's nothing left, we have to say it's a 1, okay? It's like the ghost of the third term. The third term was still there, but since it got pulled out using the common factor, we have to leave a 1 there as a placeholder. Because again, if you were to go back and distribute this right here, if you were to go back and distribute, you should still get the same answer that you had when you started. Right here, you should still have that once you do it. So let me go ahead and show you that distribution real quick. So if the 1 wasn't there, then you would check your answer and with distribution, and you'd only have 2 terms, not 3 like what you started with. So again, you must have that placeholder. So again, distribute real quick. I'm just showing you that it works. All right, so again, you need that placeholder because without that placeholder, you're only going to have 2 terms, not 3, and the original problem had 3. All right. I'm done. Thank you.